Good night. So in this video, I'm going to show how I'm going to use the water cell as a load to the resonant coil in order to lower its quality factor for allowing to search for the water tone and for a broader range without having to tune specific to that frequency for the circuit to start giving some signal of operation. Okay, so here's how it goes. If you didn't watch it, the last videos, you should watch it then and pay attention because some things are going to change. So you can watch this before and then the others, and then watch this again, and always click to subscribe and leave a thumbs up, please, to help our channel reach a greater audience. Okay, so here it goes. We get three transformers. Actually, we get these transformers, that is the VIC coil. Okay, we have the resonant coils that forms a transformer as well, and we have the tuning coil. Okay, then we have the variable resistor and the cell. I added this this counter, I don't remember now the name, but is this opposite polarity primary that kind of discharge the excess energy of the primary directly to this capacitor. Okay, so it basically participate on the dampening process of the resonance. Okay, because these coils now have some more inductance than in the previous examples, where I was using low voltage here because I was thinking only about the resistance of these coils to consider on the resonance. But actually now I'm considering it as having a two greater quality factor, and this would prevent us to have enough current in it in other frequencies other than just that very specific frequency. So we would like, I think we would need to have at least a 20% tuning range to be able to find the specific frequency of the cavity, to have a chance of that, right? So let's go for it. So here's the primary, no mystery about it. This is the secondaries, and these secondaries, you see the dot convention, they pulse the dots of the coils in reference to the capacitors. So this forms two resonance circuits that are coupled together and resonate together. So they kind of create a voltage on the water that is only in reference to this point of the coil. So that leads to these diodes, because when we get high voltage here, we want this high voltage to go to the capacitor directly, because in that way we are going to load this coil lowering its quality factor, and at the same time we are uh, allowing us to apply a higher voltage directly here, because the big thing with the resonance is that we get a capacitor. Okay, if we had a coil and we wanted to pulse this voltage without this capacitor, we would have a lot of current, right? So the thing is that the capacitor allows us to have a grow up current in this coil, but not consuming real power from the input circuit. And so here is the other secondary coil, and this is connected to a full wave bridge rectifier with a positive here that goes to the first coil here through here, and the negative goes through the other coil through here. So we have zero DC net current here, okay, generating any magnetic field. And in the middle of these two sections of secondary, or over it, we wound two turns, one turn of the feedback coil. And this feedback coil is going to capture the phase of this secondary. And this secondary is going to apply this positive voltage to the water. And when it's a light load, when water finds its tune, the current is going to drop to a very, very, very little current, because this resonance is going to take over, okay? In terms of voltage charging the water. And so this current is going to get minimal. And so the phase is going to become in phase with the primary coil. And that will help us tune exactly to the frequency of the water. When it matches this point of where this coil detects the open circuit, the phase lock loop lock in this frequency and keeps at that frequency until it loses its lock. Okay, this is the operation of the phase lock loop in the basic mode. I develop another mode where we can add a ultrasonic sensor to here, and when it locks in, it actually switches the signal from this to a ultrasonic sensor that is in here. And in that way, we can continuously track the resonance of the water and keep punching it, okay, until it has no way to survive inside the cell. Okay, so why I choose this water to load the coil in parallel? Because the water, when very pure form, for the size of the cell, it gives me around 2 kilo ohms of resistance, okay? And when it's not so pure, when it's rainwater, for example, it can get from 80 to maybe 300 ohms resistance. So this is going to lower the quality factor of this coil, allowing us to apply a higher voltage here to get the current that we would already get in the resonance. And of course we are going to expend some power for that, but that's not the question here. The question here is to find the, the, the action in the water, okay? So we are not worried about how much power we are putting in and out. We are just trying to make distilled water uh, go into fracture, okay? Going to split into hydrogen and oxygen without any chemicals, like Stan said. So this T3 transformer is going to be a transformer where is like a C core like this, but only the half part here, and then only a I core like this here, and such that I can slide, and the coil, a double coil here. So these two coils are going to be wound, are already wound on a coil former that has two spaces, and it gives around half the inductance of this coil. So I can, when it's full closed, so increasing the gap, I can vary the frequency of this resonance, okay? And this is good because we can easily tune to the water frequency, and also this this core will add to the dampening of these resonant coils, okay? And what else? Here, RCC is the resonant clamping coil. I want 300 turns here and connect directly to the DC source, because when it has 500 volts, over 500 volts here for the 100 volts applied, it's going to give 100 volts back here. So it's going to clamp the voltage of these coils to 500 volts for sake. But it's going to do that kind of economically, because it's going to do that recycling back the power to this capacitor, such that it can be posted again and again and again. So the only question is that this magnetic field is opposite. It's going to always be, as we are consuming the energy by the magnetic fields induction, this is going to not only reduce the magnetic field or modulate the magnetic field that we are applying here, but will also change the frequency, because the frequency is going to be affected because we are changing the mutual inductance, okay? So it's a consideration, because the idea of this is that if we can clamp the coil's voltage, okay, if we can clamp them, let's say we clamp, this is never going to pass over 500 volts. It's not true, okay? It's just an example. This is not ever going to pass over 500 volts because it's clamped here. When we apply over 500 volts to here, the voltage that's going to arrive here, okay, it's going to be, let's say we applied 800 volts here, and this is clamped to 500 volts. Here on the water, we are going to have 300 volts, okay, because we lost 500 here. There's a drop of voltage here. And so when when we get 300 volts here, we get how much power in? We get 500 volts worth of power here and 300 volts worth of power going here, right? Getting it simple. And that's the basic idea, because we are really wasting power here because we are generating magnetic fields for here to interact. And at the same time, we need the quality factor to drop, such that we can have at least 1 kilohertz, 2 kilohertz of band to search with the resonance scanning circuit to find the tuning of the resonant cavity. Okay, once we have the tuning, once we know the exact frequency of the cavity and the range it's going to vary within, we can then remove maybe these loads from these coils and match it exactly to this frequency and work on this narrow band. Okay, but for now, wasting power, wasting power, being in the magnetic way, magnetic dumping away, or by adding a resistor in parallel with the, or in series with the the capacitor here, or in parallel with it, or in parallel with the coil, is going to decrease the quality factor, allowing us to blast a higher voltage in through this capacitor and coil and generate the required fields, okay, at all these frequencies. Otherwise, the generated fields is going to be only at the highest peak of resonance, okay, because all the other ways is going to have high impedance, and so they won't allow uh, really other frequencies to work, to give enough power to the water such that we can really tune to it. Okay, so the idea of lowering the quality factor of this by many ways, and especially by loading with the cell itself, is that it's going to allow us to test the water from a range, for example, from 8 kilohertz to 12 kilohertz, with enough power going in here and with enough power going in here, and wasting the least amount of power possible. So I think I'm repeating myself here. You can see there's lots of drawings, lots of drawings. And this is just one of the theories that I have about the working of it. And there are others where I'm going to, other tests where I'm going to pulse these coils sequentially in order to make a field in this cell that is going to be similar to magnetohydrodynamic pump. And that's it for now. I think I kind of resumed everything here. Oh, the last thing, last but not least, this resistor in series with the cell is only restricting the DC current that is being applied to the cell from this coil and from the secondary coil here also. But this resistor is only, let's say, allowing for the quality factor actually to increase a little bit and be more linear, because when the cell is in tune, this resistance is going to be actually much smaller than the cell resistance. I am estimating that the cell resistance is going to increase from, let's say, 300 ohms to over 300 kilo ohms, maybe 1 mega ohm. And so that makes the cell a really big resistor in relation to this. Okay, so this is going to be negligible next to this, but this is important to keep the resistance big enough to allow this to resonance to at least happen and be equilibrated. Okay, and also I already talked about the resonant clamping coil. And that's it. Let's make a graph just to make a drawing to make you understand. Okay, so this is a basic resonant graph. Here you get the resonant peak, and if we try to lower the resonance with this clamping coil, this voltage is going to reach some level and remain stable and then go down. Okay, that's why I said we can apply safely a higher voltage in, because it's not going to peak like this. It's going to be much like this. If we apply a higher voltage, it's going to be much like this. Okay, and that's the secret, because in that way we can apply the magnetic fields and the electric fields in a very hard manner to the water, okay? And that will make it supposedly get to the resonant action and liberate gas economically, okay? The last thing is that this coil, as I explained in the other videos, is low coupled with the primary coil. So here we have the primary coil, and below the primary coil we have this coil, and above the primary coil, and this is other primary coil, we have this other coil. So these coils are very well coupled to the primary coil, okay? While these are on the other side of the transformer with a gap, okay? So these have a leakage inductance to added to it. And this is why whatever current flow here, very small current flowing here, it's going to make its phase delay, okay? But more than that, when we add this coil in series with this other coil here, this is applying actually some more voltage in opposite direction to this coil. That's why we get phase reversal completely when this coil becomes a light load, okay? Because when this coil voltage is low in reference to this voltage, and the current flowing is it's good enough for this to handle, the phase is not going to be reversed, okay? Because why the phase is reversed? Because this voltage is actually applying voltage in this coil, because this coil cannot give enough current to this, because its current is restricted by this leakage inductance that we get from the gap on the primary coil. So that's the genius thing about it, because we basically detect the phase, just the correct phase, only when this becomes an open circuit, okay? And that's really genius. One thing that I didn't consider here actually is that this voltage is not going to be, is possibly not going to be in phase, actually it's not in phase with the maximum current on this coil. And why that matters? Because we want the the power on the water to be applied in phase with this current, because this is what's going to make the interaction there inside. And to make that, what we need to do, we need to add an inductor, okay, to the cell in series. Maybe let's put it here together with this capacitor, okay. So we can add basically an inductor here to get this phase of this voltage 90 degrees, okay. And in that way we can get the current in phase, the current in the cell in phase with the maximum current in this resonance, okay. That will increase the force tremendously. And that's it. Wish me luck. I hope it works for real. And if it doesn't, we are going to try other things. Actually, here I'm expecting to try to find some kind of transverse resonant at the beginning, and maybe multi-pulsing. It's a different configuration, but maybe multi-pulsing these magnetic fields, we can get some other types of testings in the future, so nothing is ever loose. After all, I'm working on this since 2006, and there's a lot thing to do still. So I hope you have a good night, good dreams about it. If you have some news, reach me and tell me what you find. You please subscribe to the channel, comments below. You can add your questions, your ideas about it. You can tell me I'm wrong here. Oh no, you're totally wrong. Stanley Meyer did that. Whatever. You can say whatever you want. Internet is free. So still free. So I'm waiting for your feedback. Tell me if you understood at least what I'm doing. And good night again. Bye bye.